Next topic is two-way ANOVA. And the difference between one-way ANOVA and two-way ANOVA is that for one-way ANOVA, we're dealing with one factor. So in the example that we had earlier, we're dealing with the distance traveled. So this is one factor. For two-way ANOVA, we're dealing with two factors. So we have factor A and factor B. And the assumption that we have for two-way ANOVA is that we're assuming the population are normally distributed. We're assuming that we have equal variance, and then we're assuming that we have independent random sample are selected. So I gave you the formula here for R. R represent the number of factor A. R is your row. C is your column. So column equals to number of level of factor B. And then we have N prime, number of replication for each cell. And then we have N. N is the total number of observation in all cells. So N equals to R times C times N prime. And when we use two-way ANOVA, as for example, I gave you here, we're looking at the two factors of interest on the dependent variable. We want to see the percentage carbonation and the line speed on soft drink bottle process. We want to see how these two factors can affect the soft drink bottle process. Another example that I gave you here is what we're looking at is does the effect of one particular carbonation level depends on where the line speed is set. So we're looking at the interaction between the different level of these two factors. And for two-way ANOVA, we have different decision rules because we have different factors, right? We have factor A, so we can test for factor A when we're testing for factor A. This is the hypothesis testing that we're dealing with. And our F statistics is MSA divided by MSE. And then when we're looking at factor B only, so when we're looking only at factor B, then our hypothesis testing is here. And then our F statistics is MSB divided by MSE. So in addition to looking at factor A and factor B, what we have is we can look at the interaction between factor A and factor B. And this is what we're testing for H0 and H1. For H0, we have the interaction of A and B is equal to 0. So there's no relationship, no interaction. And what we want to prove is H1, we want to prove that the interaction of A and B is not equal to 0. So there are three types of testing that we can do when we're dealing with two-way ANOVA. And this is the table that we get when we run the ANOVA analysis for two-way. And you need to know the relationship again. You need to know the relationship between these variables. You need to know the relationship between sum of square, degree of freedom, and mean square. Right? So mean square equals to sum of square divided by your degree of freedom. And that applies for factor A, same for factor B, and same for interactions. So you take the sum of square and you divide it by the degree of freedom and you get the mean square. And for calculating F statistics, what you do is you take the mean square and you divide it by the mean square of the error term. So you take the, for example, for factor A, what you do is you take the mean square of A divided by the mean square of the error term. If it's B, then you take the mean square for B divided by the mean square for the error term. And that will give you the F statistics.